Welcome. Let us study what is energy stored in a capacitor. What is energy formula is nothing but work done. Work done is equal to integration of force into displacement ds. What is force? Q into E into ds whole integration, and integration of Q we know. What is the formula for Q? What is the formula for Q? The Q formula is Q is equal to CV, because C equal to what? Q by V, so Q equal to CV. Don't forget. So this is CV into E into ds is what? Your E into dr is what? dV, potential difference. You have already derived. Minus, let us not take minus because we are considering with the magnitude value only. Okay, so this is C into V, instead of E into ds it will be dV, right? So C will be outside the integration, right? So this is C outside the integration. Integration of V dV is what? C, this is V square by 2. V's integration is what? V square by 2. This is half CV square, right? So this is C into V square by 2 equal to half CV square. Clear? Welcome students. Let us now study combinations of capacitors. Okay, there are two kind of combination. One is series, another one is parallel. Let us see in detail. Okay, this is known as the series connection. These are the parallel plate capacitors, right? C1, C2, C3, and this is the voltage supply V. So as according to the figure you can get to know that these all are connected in series. That is, the second plate of the first capacitor is connected to the first plate of the second capacitor, and so on. Okay, these repeated things will be followed, and these kind of things are known as series connection, right? And in series connection, here suppose the charge is flowing as Q. Okay, so due to Q charge, suppose you are providing here plus, this is the sign of plus, this is minus. If you are providing plus, here the plus will be created, and because of this plus, you know it very well, due to induction the minus will be created this side, and this side plus will be repelled. Okay, again this same plus goes to here, right? And due to induction, here again minus, and this side plus repelled. Again this plus will go to this side, like this. Okay, the same charge is flowing, right? The same charge is flowing and doing the same action, right? So my Q is same. Okay, and here to here, while going the charge, while the charge goes from this plate to this plate, it does some work, and due to doing work upon a charge, you know it very well, it will create a potential difference V. Okay, and this side also V, V1, this side also V2, this side also V3, right? The potential differs. Okay, here the potential is being divided. Suppose my potential difference here is 20, so it should be arranged, these capacitors are made in such a manner so that it will provide 5 plus 10 plus 5. 5 plus 10 plus 5, what should be the whole amount? 20, or 10 plus 5 plus 5, or whatever may be the fraction. This is just an example, right? So what I told, the charge will remain same, but what is being divided? Potential, because you are doing different kind of work. Okay, because the capacitors are not same, so you are doing different kind of work in different capacitors. So work done upon a charge is potential difference V1, V2, V3, and these are being divided. Okay, so if V is divided, so as my potential is being divided, let us write V equal to V1 plus V2 plus V3. Okay, so we know the formula from the capacitor, that is Q equal to CV. So what is my V equal to? B equal to Q by C. So what is this one? This is known as equivalent capacitance. So V equivalent voltage. So V1 plus V2 plus V3 will give you the equivalent voltage V. So this will be, if I will place the value here, this will be Q by C equivalent is equal to, this will be Q by C1 plus Q by C2 plus Q by C3. And you can observe here why I am writing Q is same, because the same charge is flowing in the series connection, right? So if you cancel all the Q's, 1 by C equivalent formula is 1 by C1 plus 1 by C2 plus 1 by C3, right? So this is the formula for a series connection. Now let us go for the parallel connection. So this is the diagram of a parallel connection. See, these all are connected in parallel, and this is my voltage supply C1, C2, C3. Okay, capacitors. Okay, so now check what is a parallel connection. See, if all capacitors plates, one plate, the first plate is being connected, all capacitors first plate, this is the first plate, this is the first plate, this is the first plate, where it is being connected to the positive terminal. And see, this capacitors negative plate and negative plate, where it is being connected to negative plate of the voltage supply. Okay, so this kind of connection is known as parallel connection, right? And here, if you can observe, that is the potential, whatever you are provided here, whatever you are providing here is same across this one, is same across this one, is same across this one, and is same across this one, because this is connected like this to here, and this one is connected like this to this plate. So whatever is the voltage supply of this one will be the same as the voltage at this terminal, right? At this terminal, right? Here also 12 volt, here also 12 volt, here also 12 volt, and here also 12 volt. Why? You can see clearly, because this is the first plate is being connected to the plus and second plate is being connected to the minus. So if it is 12 volt, clearly it is being connected here. So what is the voltage supply? 12 volt. So potential difference is constant here. V is constant. So which one is changing? Charge. Here you have provided the charge Q, and at this point the charge is being divided. This is Q1, this is Q2, this is Q3. Directly you can write it as Q equivalent charge is equal to Q1 plus Q2 plus Q3. As we know the formula, what is the formula? Q equal to CV. Let us place it here. Q equal to CV. C, that is equivalent, this one is equivalent charge, so this is equivalent capacitance, into V, CV equal to C1 V plus C2 V plus C3 V. Why I am writing V as similar? Because already I told V as constant. So if you cancel all the V's, what will you get? C equivalent equal to C1 plus C2 plus C3, right? This is known as parallel connection of capacitors, right? And what is the main thing in parallel plate? The potential is same and the charge is being distributed. Why the potential is changed? Due to its construction. right? And the positive plate of the voltage supply is connected to all the first plates of the capacitors, and negative plate is connected to all the second plate of the capacitors, right? Thank you.